Willkommen zur ersten Section von inf-b. Mein Name ist Dominik Herrmann und ich kommentiere heute für Sie die erste Section von CS50 für Sie. Das Ziel dieser Sections ist es, die Lücke zwischen Vorlesungen und Übungen zu überbrücken. Im folgenden Video wird Ihnen Carter Senki, das ist einer der Kursleiter von CS50, erklären, wie man die Konzepte aus der Vorlesung in die Praxis umsetzt. Wir werden uns dazu noch einmal einige Themen aus der Vorlesung ansehen, zum Beispiel Variablen und Datentypen, Benutzereingaben und Ausgaben, Funktionen, Schleifen und Bedingungen. Um Ihnen den Einstieg zu erleichtern, wird das Ganze durch Live-Coding-Sessions aufgelockert. So bekommen Sie also die Möglichkeit, die praktische Anwendung direkt zu sehen. Zusätzlich erhalten Sie einige hilfreiche Tipps für die erste Übung. Bitte wenden Sie sich bei Fragen zum Inhalt natürlich nicht an Carter, sondern an die Tutorinnen und Tutoren des Kurses inf-b.
Okay, well, hello one and all, and welcome to CS50's very first section. My name is Carter Senki, one of the course's preceptors here on campus.
Es geht los mit einer recht ausführlichen Erklärung von Variablen und Datentypen. Dies sind grundlegende Konzepte, die Sie für die Programmierung unbedingt verstehen müssen. Carter wird Ihnen gleich anhand einiger Beispiele erklären, wie man diese in der Praxis verwendet. Hören wir doch mal rein.
Could have some value, but what makes this piece special is that it has some particular name. In this case, if we're building a contacts application, we could say this variable's name is calls. So this variable, this container for some value, now has this name called calls. And calls could store really any particular value. That's why it's a variable. This value could change over time. Maybe I'm calling my sister, for instance, and maybe I'm tracking how many times I've called her. So I've called her currently 0 times, but let's say I call her, that value gets updated from 0 now to 1. Could also be 2 later on in time, maybe 3, or so on. We could think of this variable as a name for a value that can change. In this case, our variable is named calls, and it has this value, first 0, then 1, then 2, then 3, that is changing over time.
Carter macht dann damit weiter, anhand von Beispielen die Syntax zu erklären, also wie man Variablen im Code tatsächlich deklariert und verwendet. Dabei nennt er auch die 3 Hauptbestandteile einer Variablendeklaration: den Datentyp, den Namen und den Wert. Auch der Unterschied zwischen dem Gleichheitszeichen und dem Zuweisungsoperator wird erläutert. Er zeigt dann ein Beispiel einer Variablen für einen Ländercode.
You'd call them using this country code, 65, and then add their phone number right afterwards.
Der Ländercode von Deutschland ist übrigens 49. Nun geht es weiter mit einer detaillierten Erläuterung der verschiedenen Datentypen. Da gehen wir wieder etwas schneller drüber. Nun folgt ein Beispiel. Da hören wir wieder rein.
I'm trying to store this value, 65, as part of this variable called country code. But as we just discussed, everything in our computer is stored in terms of zeros and ones, these little bits that we can use to represent all kinds of things. And for the decimal number, 65, well, if we wanted to represent that in binary, it would be exactly this, 0, 1, 0, 0, 0, 0, 0, 1. This is the binary, what our computer is actually storing to represent that number 65. So underneath the hood, we could kind of see it like this. We have this value, the decimal number, 65, and our computer is actually storing what you see underneath, 0, 1, 0, 0, 0, 1, and so on. But let's say we actually change the type of this variable from an int instead to what we call a char, or a character. Here we're representing not 65, but now the letter A. Anyone else have an idea of why, if we change the type from an int to type char or char, we get A instead? Any ideas? So I'm seeing somebody in the chat saying, we learned from lecture this idea of ASCII, the American Standard Code for Information Interchange, and the ASCII folks, they decided that that decimal number 65, when you want to think of that value as instead a character, it represents the letter A. So here, with this code on the left-hand side, I'm saying, let's store that decimal value 65, but treat it as a character. And if we're representing a character, well, I'm not going to get that decimal number anymore. I'm going to get the actual character represented by that decimal number, which in this case is A. As we'll see later on in the course, these decisions about types actually influence how much memory we're going to use and how we actually store the data on our computer underneath the hood. So more on types a bit later.
Nach den Erklärungen zu Datentypen geht es weiter mit einem anderen wichtigen Thema, den Operatoren. Damit können wir Variablen manipulieren und Berechnungen durchführen. Carter zeigt verschiedene Operatoren und führt auch das Konzept des Syntactic Sugars ein, sogenannte Kurzschreibweisen, die den Code kompakter und lesbarer machen.
Being 5, so you're correct. Calls in this case would be 5.
Das einfache Beispiel hier haben wir übersprungen. Jetzt kommt aber ein zweites Beispiel, das interessanter ist. Hier hören wir genauer rein.
Let's say we take a look at this next set on the left-hand side. What would be the value of calls now? Here again is our code. What would be the value of calls? Now I'm seeing a few options. So I'm seeing 4.5, and I'm seeing 4. And I'll ask you, which one of those do you think is correct? 4 or 4.5? So let's walk through this step by step. We have calls first being 4. We'll add 1, which makes it 5. Subtract 2, which makes it 3. Multiply that by 3, which is now 9, because 3 times 3 is 9. And divide 9 now by 2. And technically, if you were doing it on your own head, you might think, well, 9 divided by 2, that's 4.5. But actually, it'll be 4 in the end. And I'm curious, why do you think it will be 4? I'm seeing somebody saying that it's 4 because we're storing an integer. And you're correct. So calls here, up front, we said call is going to be an integer. That is a whole number. And if we take 9 and divide it by 2, we get this decimal number, 4.5, also called a floating point number. But because calls is strictly an integer, it can't store 4.5. So what will happen instead, in C, we'll simply do what we call truncating that value. We'll say we have 4.5, there is some decimal value after that decimal point, but we're going to simply get rid of it, not care about it, and take whatever whole number we see up front. So if our calculations yielded 4.1, what would we get? Well, just 4. If we even had 4.8, we'd get simply 4. So to be clear, it's not rounding, but it is truncating, taking off that last bit of the decimal place there.
So, nachdem wir die grundlegenden Operatoren kennengelernt haben, wird es jetzt etwas komplexer. Im nächsten Abschnitt geht es darum, wie wir Eingaben von Benutzerinnen und Benutzern entgegennehmen und Text auch wieder ausgeben können. Carter erklärt hier die Funktion getInt, die in unserem Kurs zur Verfügung steht. Damit können Sie einfach Zahlen einlesen. Die Funktion nimmt einen String als Argument, der dem Benutzer oder der Benutzerin als Aufforderung angezeigt wird. Wenn die Funktion aufgerufen wird, wartet das Programm auf die Benutzereingabe und gibt dann den eingegebenen Wert zurück. Dieser Wert wird dann in einer Variablen gespeichert. Es ist fast so, als würde die Zuweisung der Funktionsaufruf, es würde in der Zuweisung der Funktionsaufruf durch den eingegebenen Wert ersetzt. Als nächstes geht es um die Ausgabe auf der Kommandozeile. Das hören wir uns komplett an.
To print things in C, we'll use this function called printf. So here we have that same line of code. Int calls gets the value 4. Notice how now calls is storing that value called 4. But now on the bottom, we see calls is %i \n, comma, calls. And that seems a little cryptic, so I'm curious, for those of you who are here, what do you think will actually get printed out if we were to run this line of code? What will we actually see on the screen? So I'm seeing, we'd literally see the text, calls is 4, the actual value 4. And to show you here, we'd see this. Calls is, again, that numeric value 4. And this is a special property of printf. You might be wondering, well, why is there an F at the end? Turns out that F stands for formatted. So I'm going to print something that will be formatted. And I have, on the inside of this string, if you will, calls is %i. I will replace that %i with the value of this variable called calls. Now the follow-up question is, well, how did I know to put the value of calls in that placeholder, %i? Well, what I did is I followed up my text, denoting quotes here, calls is %i \n with a comma, and I gave another input to printf, this time I said I want to put in the value of this variable named calls. So whatever follows your text that you give to printf by a comma, whatever variable you include there, the value of that variable will be included inside whatever format code you've included there, or in replacement of that format code itself. So there are a few other format codes you're probably familiar with. A few of them look like this. We have this one for integers, %i, that we saw earlier, one for floats or decimal numbers, %f, one for characters, %c, and one for strings, or actual, not just single characters, but whole collections of text like we saw earlier. That would be %s. So you'll see these.
Nun kommt ein praktischer Teil. Gezeigt wird dies anhand der CS50-Entwicklungsumgebung im Browser. Sie können diese Schritte auch auf Ihrem eigenen Rechner nachvollziehen, wenn Sie VS Code mit einem Dev-Container eingerichtet haben. Eine Anleitung haben wir Ihnen auf der Kursseite bereitgestellt.
So far here, what we'll do is actually get some practice writing code. So I think this is enough review of lecture so far.
In den nächsten Minuten erläutert Carter ausführlich, wie man dieses Hello World-Programm aus der Übung programmiert. Das schauen wir uns im Ganzen an.
In this case, we're going to write a program that simply says hello world to the user, and of course, perhaps to the world. So I'll go over and I'll open up cs50.dev. So you should see something a bit like this if you were to go to cs50.dev and log in with your GitHub account. No need to follow along exactly like this, but if you're watching the recording, you certainly can. Notice how I have a few different areas in cs50.dev. I have a top area up here that will soon be able to have a file that I can actually edit things in. And down below, I have this place called the terminal. I can kind of interact with this computer that I've loaded up in the cloud. So now connected to some other computer, not my own, or actually write my own code, and where we, CS50, have installed some software for you to actually write C code very easily. So let me try, in this case, to open up a file called hello.c. I'll type code hello.c in my terminal. Let me zoom in a bit so y'all can see that. Here I now have code hello.c. I'll hit enter, and I'll see this blank file up top called hello.c. So now, I actually go ahead and type in some C code. Maybe I want to say hello to the user. What's the first thing I should do? For those of you who watched lecture, what might I need to do at the top of my file? I need to include some stuff, as people are saying. So in CS50, and actually in C in general, we have this idea of a library, or some code somebody else has written for us that we could then use in our own program. And it turns out that somebody else wrote this function called printf, and because they wrote it and included it in this library, we can then actually use that function in our own code without worrying how they made it. We just kind of know that it just works. So to get access to functions like printf, I can type this special piece of syntax up top. I can say #include stdio.h and hit enter here. So this is allowing me to include this file called standardio.h, a header file that has printf defined inside of it. And now what's the next step I might need to do here? I have standardio included, but how would I might start off my program as we usually do in C? So I'm seeing we need to make a main function. So by convention in C, we want to make a new program. We always include that entire program inside this function we call main, int main void. And now, here I have, let me fix that formatting here. I have this function called main. Yours might be syntax highlighted. Not quite sure why mine isn't highlighting here, but I'll resolve that a little bit later. So here we have int main void, and we could type in our actual code inside of this function that we are calling main. Now what kind of code could we type to say hello to the user, based on what we saw a little earlier? What function should we use? Probably printf, right? So I'll say printf, and then why don't I do this? I'll say hello world. And now, if I hit a period here to say a sentence, \n, I should be able to hopefully run this program down in my terminal. So let me try this. If I want to run, I could try saying /hello and hit enter. But I get this error. No such file or directory. So what did I actually miss in this case? Yeah, so you were saying I forgot to make this file. So as we saw in lecture, there's this idea of taking the source code, that is this C file, and compiling it to machine code, or the zeros and ones a computer actually understands. So to take this C code and convert it to the code a computer understands, we have this special program called make, which is a compiler that simply says, take whatever is in hello.c and convert it for me to an actual program my computer can run. So in my terminal, I will choose to make hello, hit enter, and now nothing seems to happen, but that's actually a good sign. If I type ls to list my files, I'll see hello star, which means this is a file my computer can run. I'll say /hello, hit enter, and now I see hello, world. So syntax highlighting aside, which you should hopefully see in your own code space, this is how we could actually write our own hello world program. What questions do we have then on these lines of code? I'm seeing a question here. What is the difference between a library and a header file? So that's two pieces of vocabulary we've used here. We often say we're going to include a header file, or conversationally include some library. But there's a difference between these two things. So notice how this, stdio.h, that is an actual file we're calling a header file. And in this particular file, we've defined all the functions that are included in this library, like, for example, printf. But in that header file, we haven't actually defined the entirety of the printf function. We've just defined a few particular things, like what inputs printf takes or what outputs it gives to us. Now, the entire library likely has more files than just this header file, under which those functions are actually defined, under which they tell us what exactly does printf do. So the library in general, you can think of it as including all kinds of functions, some like printf, but the header file is our way of defining what functions are inside this library to begin with. A great question. So let's keep going and make this a little more advanced. So our next step in problem set 0 is to not just say hello to the world, but to say hello to a particular user. So in this case, you want to get input from the user and allow them, in this case, to say hello back to themselves. So I'll go back to my program, hello.c, and now I want to get input from the user. So what could I do? Maybe I want to make a variable. And I'll actually ask you all who are here, what kind of variable should I make? If I want to store some text from the user, what type might be good for that? So I'm seeing a string. A string is a variable that can store a collection of text, not just a single character, but a whole collection of it. So I'll type string here, which is the type. And now what should I name this variable? What might be an appropriate name here? We could just call it name. This is a variable whose name is name because it stores someone's actual name. Kind of confusing, but we'll go with it. String name, and then it gets some value. So I'll use this assignment operator here. What value should it get? I could type just Carter here like this to get my own name, but I want to get the user's name. So what could I do? I'm seeing I could use getString, as we saw before. So getString is a function that is included in the CS50 library that allows you to safely get some user input that is a string. And as input, inside these parentheses here, getString can take some piece of text itself, or a string. So I'll say, what is your name? And leave a space so the user can type in their name after that. And now, down below, I should think about what I should update here. I have hello world, but now what should I change this to? Not hello world, but what? Probably a placeholder, right? As I'm seeing some folks say, I want to have a placeholder for this variable we created called name. So I'll say hello, comma, and then a space, %s. %s was our format code, our placeholder for a variable of the type string. And now how could I make sure that the value of name gets included here? I could simply follow this text with a comma, then say the variable name, and now I'll make sure that whatever value is stored by this variable called name, I should be able to have a placeholder for it here in %s. So now let's try it. I'll do make hello to recompile my program, update it, and turn it back into machine code. I'll hit enter, and I get a fatal error. Let's see. What might be wrong? So there's a few clues here. Use of undeclared identifier string. Did I mean standard in? It's actually not what I meant in this case. But often if you'll see, you might get some errors saying something is undeclared, undefined in some ways. When that happens, you might want to take a look at which files you're including at the top of your program. And in this case, I told you that getString was included in the CS50 library, but I didn't include it up top. So let me go ahead and include. I'll say hashtag include, and then cs50.h to include that cs50 header file. And just for style's sake, what I'll do is actually move cs50 above standard IO just to keep things alphabetized up here. So C comes before S. I'll make sure I have all my header files alphabetized just for style's sake. It would work the other way too, but just to keep things a little cleaner around here. So let me try this. I'll say make hello, hit enter. Nothing seems to happen, which is good. I'll type ./hello to run my program, hit enter. I'll see what is your name, and I'll type Carter, and I should see hello, Carter. So all seems to work in this case. Now, what questions do we have on writing our very own hello to you program? Seeing none so far. And now let's move on to something that's a little more advanced. Actually, there's one question here. So why do we put name after %s \n? So it's kind of just by convention. The people who wrote printf, who came a little bit before us and made this function, they simply decided that printf would take one or more inputs. So here I say hello %s \n. And if I want to include, if I want to take the value of this variable name and put it in this placeholder, I just simply follow up with this first input called hello, comma, %s \n, and include that variable itself. If you want to get more advanced with this, you actually could. So let's say I want to take a first name and a last name. I could actually have two placeholders, hello, %s, space, %s. And now, if I wanted to include another variable, one, let's say, change this name to first name, and then have one later called last name, here's how I could use printf. I could now have three inputs separated by commas. The first is the actual string I want to print with the placeholders. The next one is the first variable to replace. That is, the value of first name will go into this first placeholder. And then the second variable, last name, that will go into the second placeholder here. So I'll update my program. I'll say, hello, string first name. What is your first name? And then here I'll say, string last name gets the value of getString, asking what is your last name, and semicolon to finish. So now I'll type make hello, and I'll run ./hello. I'll type Carter followed by Zenki, and now I'll see hello, Carter, Zenki. So some other ways to use printf if you want to actually involve more than one variable in your output. Now, building on this, let's actually continue on, and let's try actually making a more advanced program to store our contact. So I'll go back to my slides, and I'll show you this. We're going to write a program that prints out, that takes in and stores, and then later prints out a user's contact information. And so if you're going to write this program, I want you to include the following three attributes of somebody. Make sure you include, let's say, their name. You could treat it as either first name or first name and last name. Their age, and also their phone number. So name, age, and phone number. And I want you to, if you're watching this as a recording, maybe pause the video here and try to write this program yourself, then come back and we'll write it all together. All right, so if you're back from writing this program, let's go ahead and try to write it all together here. I'll go back to my code space, and this time I'll get rid of hello.c. I'll exit out up top, and now I'll type code contacts.c to create this new file that is a C program called contacts. And I'll maybe include my initial libraries. I'll say include standard.io.h and include, perhaps up top here, cs50.h as well. Now I'll type int main void, what do we do to kick off all of our C programs here. And now I need to get the information from the user. So I'm curious, for those of you who are here live, what should I be doing to actually get the user's name? Well, probably similar to what we did before. I could say string name equals get string what is your name, just like this. But now I want to get their age. And I'm curious, what type might be good for getting their age? Maybe an integer. So I could say int age equals get int what is your age, just like this. And then finally, down below, I want to get their phone number. But what type might be best for a phone number? I'm seeing a few options here. So one might be an integer, like it is a phone number, so it could just be an integer value. But it might be better defined as a string. So the difference here is that if I say int, let's say just number for phone number, get int, what is your phone number? Well, that restricts the user to entering only digits. And sometimes you might see phone numbers written with dashes or plus signs for country codes. And if I wanted to include those, well, if I have an int, I actually can't include those. So if I wanted to be able to have the user type in pluses along with numbers, a string might be good for this. So I'll say instead string number and use get string, what is your phone number? Now the user could include not just numbers like 7 or 1 or so on. They could also include parentheses, dashes, plus signs, whatever they need to enter their phone number. And now to print all this out, I'll go back down below and I'll say, let's say, why don't we print out name followed by their name. And why don't we print out, in this case, the age followed by their age using %i for our integer here. And then printf, and then number followed by %s, \n, semicolon. And now I'll be able to include all of these as placeholders, name, age, and number. And I'll be able to take the value of name and put it in this placeholder, for instance. So why don't we do this? I'll say make contacts, then /contacts, hit enter. What is my name? Carter. What is my age? 25. I'll type in a phone number. I'll say +1. Let's go with 555-555-5555 for a random phone number here. Hit enter, and now I see that same information being printed back out to me.
Damit wir interessantere Programme schreiben können, benötigen wir weitere Mechanismen von C, nämlich Funktionen, Schleifen und Bedingungen. Darum geht es jetzt.
In this problem set, you'll be tasked with making your very own pyramid, like the pyramid that's in Mario.
Zuerst erklärt Carter Schleifen. Weil Sie die für die Mario-Aufgabe benötigen, schauen wir uns diesen Teil komplett an.
So there are a few kinds of loops, and one of these loops is called a while loop. A while loop is great for when you want to maybe do something while some condition is true in your program. So as one example of this, let's say I have a while loop that looks a bit like this on the left-hand side. Well, I will tell you right now that the output of this piece of code is going to look a bit like this on the right-hand side. I'll get 4 hashes on the right-hand side. But how did we get here? Let's walk through it kind of step by step using the syntax that we see here. So the very first line of code, int j gets the value 0, well, that creates this container in memory called j that has this value called 0. And now, here's where things are a little more interesting. I have this variable, but I want to kind of do something with it. I could make a condition out of it. I could say I want to do something in my program while it is true that the value of j is less than 4. That is this condition right here. Now, what do I want to do while the value of j is less than 4? Let's say I first want to print this single hashtag down below. So now I've gone and I've said, well, is j less than 0? Or is j less than 4? It is. It's currently 0. So I'll print out a single hash. And then what will I do? I'll then say, let's increase j by 1 using the syntax plus plus, some syntactic sugar here, to say j is now 1 more than what it previously was. And now, logically, in this loop, I'll go back up to the top and I'll reassess this condition. I'll say, is j still less than 4? And for those of you who are here live, is j still less than 4? I think it is, right? So we'll keep going. We'll go through this loop one more time. I'll say print out another hash. And then I'll increase j by 1. So now, what is j? J is 2. I'll ask again, is j less than 4? It is. So let's do this again. I'll print out a hash, and I'll increase j by 1. And finally, I'll go back at the top, ask, is j less than 4? Well, it still is. It's still 3. I'll do print another hash, add 1. And now, when I go back up to the top to assess this condition, is j less than 4? Well, j is equal to 4. It's not less than 4, so we'll stop doing the code in this loop, and we'll instead print out this special character we saw in lecture, \n, that says we'll move to a new line. So that is one way, in this case, to get some set of hashes going along the bottom of, let's say, our pyramid, using some kind of while loop. But there's also another way to do this. We could think of it not just in terms of a while loop, but in terms of another tool called a for loop. So a for loop is, it can allow you to do very similar things to a while loop, but it's good for when you know the exact number of times you want to iterate. A while loop is great if you're not exactly sure how many times you want to do something, but you know you want to do it while something is true. A for loop is great when you know the exact number of times that you want to actually loop, in this case. So we could actually write that very same while loop using code a bit like this on the left-hand side. There's a few components here, though, that we need to break apart. So maybe the first piece here is going to be this part on the left-hand side. Let me actually zoom through this. Let me show you, oops, come back here. What did I want to show you? Yeah, so let's actually go back to the very beginning of this. If we go here, let's look at the very top of this for loop. So for int j equals 0, semicolon, j is less than 4, colon, semicolon, j plus plus. That probably looks familiar from our while loop, right? We had those kind of very same things in our while loop. We first set j to be 0. Our condition was, is j less than 4? And the thing we did each loop was increase j by 1 using j plus plus. So we've taken all those same components, but simply put them at the top of our for loop. And that allows us to simplify our syntax here. So on the inside, we just say what we're going to do for each iteration of this loop, which is print out a single hash. So to visualize this on the right-hand side, let's say our very first thing we do in this for loop is we create a variable called j that gets this value called 0. Then we're going to print out a single hash. We're going to ask that question again. Is j less than 4? Well, it is, so we'll do that thing we said we'd do at the very end of this for loop, j plus plus. Now j becomes 1. We'll go through, print out another hash, and then we'll say, is 1 less than 4? It still is. We'll print another hash and keep going. And now we'll see, is 2 less than 4? Well, it is, so we'll print another hash. J is 3. Now j is 4. No longer will we be printing out these hashes. That condition, j less than 4, is no longer true. We'll instead print \n to finish things off at the bottom. So what questions do we have here on the syntax for while loops and for loops, if any? A good question. Is there any difference between the while loop and the for loop other than the initial condition and the update in the same line in the for loop? Any differences? I think the main difference is more syntax. So as you see here, they're in a different kind of order as we saw in the while loop. I'm going to go out on a limb and say I think that most things you could do in a while loop, you can also do in a for loop and vice versa. Generally, though, the syntax of a while loop is better suited for you have some condition, you're not sure when it will be true, but you know what that condition is, so you'd include that in the while loop, whereas a for loop is good because you kind of get to actually specify the exact number of times you want something to do that loop over and over again. If that makes sense and answers your question, let me know. If not, I can give you another take on that. Let's see. Why is the J++ now outside of those brackets here, these curly braces that you see on the left-hand side? So that's simply the way that the makers of C decided it would be. You might see some very similar syntax across different languages beyond C, also in things like Java and maybe even Python as well. Basically, this allows us to simply make things a little more compact. We're moving that increment, what we do each loop to increase this variable j, we're moving it to the actual definition of the for loop. Nice. OK. So with these kinds of tools, I want to pose a question to you, which is, let's say we're able to get to a point where we're printing out a single line of hashes. This code here prints out a single line of hashes and moves to that new line. But let's think for a moment. What could I do to get not just a single line of hashes, but maybe even a full square of hashes? Having multiple lines now. I have one loop to make a single line. And I'm seeing an idea coming up in the chat. Maybe we could use another loop to have more than one line, like not just a single line, but maybe multiple, like 4 lines of 4 hashes to make a square of hashes. And it's actually true. You can take a loop like this and put it inside of another loop, a bit like this here. So notice how the inner loop, this for int j equals 0, j is less than 4, j++, that is still printing out a single line of hashes. But now I'm going to do that step 4 times per the for loop that is around that loop. For int I equals 0, I is less than 4, I++. The result of this will be this square pyramid, the square we see on the right-hand side of hashes.
Als nächstes geht es darum, wie man mit Schleifen die Mario-Aufgabe angehen kann. Hier wird gezeigt, wie man verschachtelte Schleifen verwendet, um komplexere Muster wie Pyramiden zu erzeugen. Statt der rechts ausgerichteten Pyramide aus der Aufgabenstellung wird zunächst eine einfachere, links ausgerichtete Variante implementiert. Das ist ein kluger Ansatz, um das Problem schrittweise anzugehen. Die Grundprinzipien bleiben dabei gleich, egal ob die Pyramide nach links oder nach rechts ausgerichtet ist. Achten Sie darauf, wie die Höhe der Pyramide die Anzahl der Schleifendurchläufe bestimmt. Diese Technik werden Sie häufig in der Programmierung anwenden. Jetzt sehen wir, wie Carter das Problem zerlegt in seine Einzelbestandteile und es Schritt für Schritt löst. Hören wir ihm dabei einmal zu.
And inside, I'll do the usual things. I'll include standard.io.h. I'll include cs50.h, these header files that have the cs50 library and standard.io library somewhat defined in them. I'll then say int main void to kick off this program. And on the inside, what's the first thing I should do? I probably want to get height from the user, but how could I do that? Those of you who are here live, how could I get a height from the user to print out this pyramid? So I'm seeing maybe I want to use something like an integer to store the height. Because again, this pyramid will be some number of blocks tall. So I like the idea. Let's go with that. I'll say int height here. And I could, for instance, say int height equals 5 off the bat. But I could probably get the input from the user using that function we saw earlier, getInt, like this. And I'll prompt the user for some height. So now it's a good idea, once I'm at some stopping point in my program, to try to compile it and see if it works. I'll then type make Mario, hit enter, and I'll type ./Mario. I'll see I'm prompted for a height. I'll hit 5 here, and nothing happens, but at least I know my program tends to work at this particular stage. So let's think about how we could use functions to be solving this problem. Now, here we have this function called getInt, but it's worth actually diving into what getInt is doing for us and talking through some vocabulary that can help us understand what getInt is actually doing. So for that, we'll focus on functions. And notice here how we can actually define getInt. We at CS50 defined this function for you. You don't see its definition in your actual code because you can only just use it now. But we did work on defining this function for you. And notice a few pieces of this function. Notice how up front we have this idea of the name for this function, this one called getInt. We could think of it kind of like that black box we saw David mention in lecture. We have some algorithm, some function that is called getInt, some black box here that's going to take an input and give us some output. Now we can also define the output of getInt. We, CSD did this part for you. We said that it will take an input, in this case, called prompt, that is of type string. So notice how when I used getInt, I typed in a string as the input to getInt. This input was called height followed by a colon. So now in this case, we see that getInt takes a string that within that function is called prompt. And then what does getInt give us? Well, at the very end of the day, it gives us back an integer. In this case, a whole number that the user actually typed in themselves. And so of course we would use this function a bit like this. We could say taking a prompt to give us back 2 or 4 or so on. But we'd use it using int height gets the value of something like this function, getInt followed by height. And when this function runs, it returns to us what we said it would return over here, something of type integer. If that makes sense. So questions then on this function declaration, what we did over here to define what getInt is doing for us. Okay, not seeing too many questions here. So why don't we keep working on our Mario program? I'll go back over here, and we saw before that I could print out a single row of hashes using a for loop, right? But maybe it would be worthwhile to consider how I could put that code that prints out a single line of hashes into its own separate function that I could use in my main part of my program, this one called main up here. So I wanted to define that, code that writes that line of hashes for me separately. I could probably put it in its own function. And to define my own function, I could probably go down below here and say something like this. Why don't I create this new function? I'll call it, in this case, print row. And what kind of input do you think print row should take? Ideally. Maybe I want to modify the length of the row. How could I say print row takes an input to modify the length? Any ideas in the chat? One thing I could do is think, well, the input to this function, I want it to be the number of hashes to print on the row. So that seems to be a number, an integer. So I could say print row takes an input called, that is of type integer, and I have to give it a name. I'll call it, in this case, length, the length of that row. And now I'll think, what should print row return to me? Well, it doesn't really return me a value if I'm going to use it. It simply just prints things out to the screen. In lecture, we saw a difference between return values and side effects. In this case, it just has a side effect. It prints things to the screen. So I'll actually make sure that this return value is simply void. It's nothing in particular. So now print row is a separate function. It has an input called length that is of type int, and it returns to me nothing in particular. It just prints things out to the screen. So now inside of print row, I could have that very same loop we saw earlier, perhaps a for loop. I'll say for int I is 0, and I is less than what? Like before we saw 4 to get a length of 4, or 3 to get a length of 3, but now I want it to be a variable length. I could decide later what I want the length to be. I'm seeing some folks saying, maybe I could use this variable that's input to print row called length. I'll try that. I is less than length I plus plus. So now, when I use this function print row, I could pass in some number, and then I'll loop that many times in my for loop. And what will I do for each loop? Well, I'll print out, in this case, I will print out a hash each time. And at the end of all that looping, I'll print out simply \n to move to a new line. So this is my print row function down below. Now if I go up top, I could try to use print row. I could say, well, I want to print a row that has the length of 4, like this. So I'll first get the input of height from the user, and I'll not use it for now. I'll just use print row with the value 4. I'll go to my terminal here, type make Mario, hit enter, and I seem to be getting an error. What is the error? You'll see here, implicit declaration of function print row is invalid in C99. What ideas does that bring up for you here? What might I be doing wrong? Yeah, so it seems to me I haven't actually included what we're calling the prototype for this function. So if I look down below here, actually if I read my program top to bottom, like C would, I'll see I'm going to include some files, have a main function, get the height, and then call this function, or use this function called print row, and give it the value 4. But up until now, if I'm reading top to bottom, I actually haven't seen the definition for print row. Where is it? Well, it's below. It's down here on line 10. But I can't be calling this function if I haven't told C that it's going to come up in my program yet. So what I should do instead is take the function prototype, that is, its name, its input, and its return value, and put it at the top of my program, often by convention below my includes, and I'll follow it with a semicolon here, saying this is my function prototype. This is the line of code that tells C, I promise I'm going to define for you what print row is later, but for now, just let me use it when I say I'm going to use it. So now, in main, I'll see, hopefully C doesn't actually complain when I use print row, because up top I told it exactly what I'm going to use as well. So now I'll type make Mario, hit enter, and that seems to work. So now I'll type /Mario, hit enter, say the height is 6, hit enter, and I get this, this line of only 4 hashes. But what could I do to update this program to print out not just 4 hashes, but the same number that the user typed in? Probably want to modify this piece here, but how could I modify it? Yeah, I'm seeing some ideas. I could probably use this variable called height. So we know that this variable called height is a container for the number I typed in this case 6. So if I want to pass in that same value to print row, for it to print out a row of that length, I could instead say print row, parentheses, height, and save that. Now I'll type make Mario, /Mario, and type in a height of 5. Now I get, in this case, 5 hashes down below. And notice in particular that in this case, the name of the variable that I am what we call passing into or inputting to this function print row, that is not the same as the variable I said I would get down below, this integer called length. What actually happens is height, we have storing a value, in this case 5 down below. That value for height is given to print row, and as long as I'm running the code in print row, that value 4 will be associated with this name, length in this case. So I took the value that height stored, 5, I gave it to print row, and as long as print row is running, that value 5 is now called length in the context of this function, print row. We call that this idea of scope in computer science. So here we have a way to take the user's height and a way to print a row of that height. We're not quite all the way there yet, but what questions do we have on the code so far? I'm seeing a question here. Is there any situation where not prototyping, but declaring the function above main would be better? So notice here we had the prototype for print row above main, but we had the definition for print row below it. Now, I think the question is asking, is it ever useful to do essentially this, to copy and paste, to cut and paste this, and put it above main, a bit like this? You certainly could, but I find it more readable in this case to have the main function up first, because when we run our program, the main function will always be the first to run. So more style for style's sake than anything else in this case. Question here, in line 4 and 12, you have declared void print row int length 2 times. Why is that OK? Because we can't do that with variables. That's actually a good observation. So if I were to, for instance, on line 8, create a variable called height, and then later on create a new variable called height, like this, I would find that C, when I try to compile my program, doesn't like that. I can only have one variable under one name at the same time. I can't have 2 variables with the same name. Here, though, it seems like I have 2 functions with the same name. I have one called print row up here and print row down below. And I think the answer to this is that it's a built into C is this syntax that if you have a function you want to use and it's defined later in your code, you simply copy and paste the prototype, its name, its input, its output, put it at the top of your file, and C knows this is a function that will later be defined. It's not a separate function with the same name. And one more question here. Why is height printing length when logically height is up and down and not left to right? That's a great question. We're going to fix that in just a moment. So here we noticed that in my separate file, I'm going to make code pyramid.txt. If I wanted a pyramid of height, let's say 3, notice how the bottom row has length 3 in this case. So a pyramid of height 3, the bottommost row, that has the length of 3. But also notice how above, this has length 2, and then length 1 up top. So there's probably an association between the height and the actual length of these rows I'm printing. So what if we tried something a bit like this? I know I want to print more than one row, and I probably want to do it in a way that it involves a loop. We saw a loop as a way to do things more than once. So I could say maybe something like for int I equals 0, I is less than, well, how many rows should I print in this case? If I have a pyramid of height 3, how many rows should I print? Seems like 3. So I think in this case, it's safe to loop height number of times and increase I by 1 every time we go. So now, inside this loop, I'll print row. And maybe I'll keep it the same with this input called height. So let's try that. I'll say make Mario ./Mario, height of 3. I'll get a square. So it seems like we're getting there, but I need to change something about this program. What should I change, do you think? So I'm seeing a few ideas. One is actually to use this variable here, I, that we declared and initialized inside of our for loop. So as long as we are within this for loop, within its curly braces, I actually have access to this variable I. I is what's called in scope. I could use it throughout this portion of my code. So maybe I don't want to print a row that is of length height, but maybe of length I. So first, I would be 0, and then it would be 1, and then it would be 2, and so on. So actually, if I look at my pyramid, my very first row is 1, then 2, then 3. So maybe I don't want to first print out 0, I want to print out 1. But how could I change this to not print out 0 first, but 1? Any ideas? I'm seeing maybe I could just add 1 as we go. So that's actually a good idea. Why don't I say first I is 0, but when I is 0, I want to print out 1 hash. So I'll say just take I and increase it by 1. Well, next, I will be 1 after going through this loop. Then I'll say, well, how many hashes do I want to print? Well, just one more than what I currently is. So I'll maybe say that's print out a row of length I plus 1 again. And then I will be 2. I want 3 hashes, so I'll just say I plus 1 again. And so maybe this should work. So I'll say make Mario, and then /Mario, pyramid of height 3. And now I seem to be getting somewhere. So I'll make my terminal bigger. I'll say make Mario, /Mario again, height of 5. And I seem to be getting what I'm looking for with this left-aligned.
Bevor die Section endet, gibt Carter noch einen wichtigen Tipp, wie man die Mario-Aufgabe am besten angeht. Er schlägt vor, die Funktion zur Erstellung der Pyramide zu erweitern, um sie für die rechts ausgerichtete Variante anzupassen. Statt nur die Anzahl der Hashes oder der Rautezeichen als Eingabe zu verwenden, könnten Sie die Funktion zum Beispiel so umbauen, dass sie auch die Anzahl der Leerzeichen berücksichtigt. Dies ist ein eleganter Weg, um von der links zur rechts ausgerichteten Pyramide zu gelangen, ohne den ganzen Code neu schreiben zu müssen. Denken Sie daran, gute Programmiererinnen und Programmierer sind faul, und zwar im positiven Sinn. Sie suchen immer nach Wegen, bestehenden Code wiederzuverwenden und anzupassen, anstatt alles von Grund auf neu zu schreiben. Dieser Ansatz spart nicht nur Zeit, sondern macht Ihren Code auch flexibler und leichter wartbar. Versuchen Sie, dieses Prinzip auch bei Ihren eigenen Programmen zu verwenden.
So notice how over here, in pyramid.txt, if I want this to be right aligned, I first print out some number of hashes, or some number of spaces, and then my hashes as we go, to move this pyramid from being left aligned to now being right aligned. So we'll leave you with that to consider as you solve Mario this week, but that was the section.
Und damit sind wir mit der ersten Section von inf-b fertig. Bis bald!